If wood was truly fragile, medieval Europe would not have functioned. Bridges carried armies, cathedrals rose on timber frameworks, mills turned year after year in flowing water, and harbour pilings stood half-submerged for generations. None of this relied on modern sealants, pressure treatment, or synthetic membranes. Medieval engineers understood rot not as an inevitable fate, but as a predictable process that could be slowed, redirected, or stopped entirely. What they developed was not a single coating or recipe, but an integrated approach that treated moisture, airflow, and biology as part of one system. That is why their wooden structures often outlast modern builds that rely on chemical barriers alone. Medieval engineers started by controlling where water could travel. The central insight medieval builders shared was that rot begins where water lingers. They shaped wood to shed moisture before it ever soaked in. Beams were bevelled, posts were tapered, and joints were designed to drip rather than trap. Even small details mattered. Peg holes were angled downward. Mortise openings were cut so rain could not pool. This approach did more than any sealant because it prevented moisture from staying long enough for fungi to take hold. Today, the same logic can be applied by chamfering edges, sloping exposed surfaces, and, avoiding flat horizontal timber wherever possible. They harvested and seasoned timber with biological decay in mind. Medieval engineers knew that fresh wood rots faster than dry wood, and they adjusted their schedules accordingly. Trees were often felled in winter when sap levels were low. Sap contains sugars that fungi feed on, so reducing it reduced decay risk from the start. Logs were then air-seasoned for years, not weeks. Stacked off the ground and protected from direct rain, they dried slowly, collapsing the internal capillaries that draw water inward. This step alone dramatically reduced how much moisture the timber could ever absorb. Modern builders can, copy this by choosing air-dried lumber and storing it properly before use, instead of just rushing to install it wet. They used fire and heat as controlled tools rather than destructive forces. Fire was honestly one of the most underestimated medieval anti-rot tools. Posts destined for ground contact were often passed through flame or hot embers. This did not burn the wood away. It actually hardened the outer layer, reduced porosity, and destroyed nutrients fungi require. The charred surface also resisted insects. Unlike paint or plastic coatings, this barrier could not peel off. Even when scratched, the underlying wood remained less absorbent. Medieval buildings were, smoky by design. Roof timbers, rafters and wall beams absorbed smoke year after year. You see, smoke deposits natural preservatives like phenols and resins into the wood, making it hydrophobic and, honestly, rather hostile to mould. The warmth also drove out residual moisture without cracking the grain. One of the greatest mistakes in modern construction is, unfortunately, trapping wood between impermeable layers. Medieval engineers, though, avoided this instinctively. Timber frames were exposed to airflow. Even when enclosed in plaster or masonry, air gaps were left so beams could dry after getting wet. Moisture that can escape rarely causes rot. Moisture that cannot escape always does. Where coatings were used, they were chosen for compatibility, not hardness. Oils, tallow, lime washes and pine tar soaked into fibres instead of forming brittle skins. These treatments repelled water while allowing vapour to move. They aged with the wood instead of fighting it. Reapplication was simple and honestly quite predictable. Modern sealants promise permanence, but, they fail when reality intervenes. Cracks form, water gets in. Trapped moisture accelerates rot. Medieval methods assumed water would always find a way, so they focused on making sure it could leave. If you want wood to last, start with dry timber. Shape it to shed water. Keep it ventilated. Use fire, smoke and breathable oils instead of rigid coatings. Elevate it from soil or fully commit it below water. None of this requires chemicals or specialized tools. It really just requires understanding wood as a living material, not an inert one. If you value serious history, practical building knowledge and time-tested engineering that still works today, make sure you subscribe to Backyard Wisdom and share this video with others who want to build things that truly endure.